Let's look at OpenStax University Physics Volume 2, Chapter 10, Problem 39. Consider the circuit shown below. Find V1, V2, and R4. So there's a lot of stuff in this circuit. We have two power supplies, and we have 1, 2, 3, 4, 5 resistors. We're given directions for currents and the values for the currents, and we're looking for the voltage 1, voltage 2, and resistance 4. So V1 is part of this loop. It's part of several different loops, but I'm going to look at this particular loop here because I know that the current here is 4 amps, so that means that the current starting at this junction and going through this resistor and ending at this junction is 4 amps. Then I know that the current going through the 6 ohm resistor here is 1 amp. So from this junction to that junction, there is a 1 amp current. And then from this junction to that junction, there is a 3 amp current. So there's a 3 amp current going through R2. So I know everything in the circuit except for the voltage, so I can use the loop rule. So first thing I'm going to do is label the ends of the resistors with pluses and minuses. So we have a potential here. This is the highest potential. And as it's passing through the resistor, there's a potential drop. So that means that this end of the resistor is at the higher potential, that is at the lower potential. So I'll label that with plus and minus. Then similarly here, this end of the resistor is at the higher potential, that is at the lower potential, this is at the higher, this is at the lower. So we went around and labeled all of the different resistors with high potential, low potential, and so on. And the battery is already labeled as such. So the next thing I want to do is go around the loop, and I'll just go around in this direction. Let's say that I'll start here and write that sum of the potential drops is equal to the sum of the potential rises. So that is Kirchhoff's loop rule. Potential drop means that I'm going from a higher potential to a lower potential through a circuit element. Potential rise means that I'm going from a lower potential to a higher potential. As I start going from here in this direction, I'm going to go through resistor R2 with current I2 from a higher potential to a lower potential. So this goes on the drop side of the equation. So I'm having I2 R2 over here. Then I'm going to go through the battery from the negative to the positive. So from a low potential to a high potential, that means that it's a rise. So that goes on the rise side of the equation. Then again, I'm going from the higher potential to the lower potential through resistor 1 with current 1. So that would be on the drop side, and we'll call that I1R1. And then I'm going to go through a resistor R3 with current I3, again from high to low. So that's another drop. So that will be I3, R3. And we're done with the loop. We made it all the way back to here. So we have 1, 2, 3, 4, 1, 2, 3, 4 parts to our equation. And now we can solve for V1. So V1 is I2, that was 4 ohms. Sorry, I2 is a current. I2 was 3 amps times 4 ohms plus 4 amps times 6 ohms plus 1 amp times 6 ohms. So when we're plugging this into our calculator, we end up with 42 volts. So V1 is 42 volts. So now we want to know what V2 is. So I'm going to use this loop because in this loop I know R and the current, I know this R and the current. I could have used this loop, but I don't know this R. So I'm going to go around this loop and I will label my pluses and minuses again. So current I5 goes to the resistor, and this will be the higher potential, that's going to be the lower potential. So this is plus and this is minus, and then that's minus plus. And I already have the pluses and minuses labeled here. So now I'll just have to pick direction to go around the loop. So I'll just pick another clockwise and start at this point. So I'm going to go first through the battery from minus to plus. That will be a rise. So rise is over here, that's V2. Then I will go through R3 from minus to plus, that is a rise. So I have plus I3, R3. And then I will go through R5 with current I5 from plus to minus, so that is a drop. So it goes on this side of the equation, I5, R5. And we're done. We have 3 voltage drops here. So now we solve for V2. So V2 is I5, R5 minus I3, R3. So I5 is 3 amps, R5 is 4 ohms, I3 is 1 amp, and R3 is 6 ohms. So that's 12 minus 6, or 6 volts. So now we know both the voltage 2 and voltage 1. So I will write on here that V2 is 6 volts. And now I'm looking for this resistance, so I can use this loop and write the sum of the potential drops and sum of the potential rises to figure out what the resistance is. So before I do that, I still have to label my pluses and minuses. So going with I4 through R4 from bottom to top, this will be the higher potential, that's going to be the lower potential. So the bottom is plus, the top is minus, and everything else is labeled. So I will have to go around a loop, and I will go again clockwise, and I will start at this point. So I'll rewrite down here sum of the potential drops equals sum of the potential rises. Again, a drop is from plus to minus, a rise is from minus to plus. So going through resistor 4, I have from plus to minus, so that's a drop. So I4, R4 goes on the drop side. R2, we're going in this direction from minus to plus, so that will be a rise. So that is I2, R2. And then we'll continue going through V2 from plus to minus, that is another drop. So that goes on this side of the equation. And when we solve for R4, it's I2, R2 minus V2 divided by I4. I2 is 3 amps, R2 is 4 ohms, V2 we calculated to be 6 volts, I4 is 1 amp, so we end up with 6 ohms for the resistance through R4.